Hi there. As the year winds down, this is one of the last few videos you'll have to deal with watching me teach you something. So today we're going to cover solving logarithmic equations. And you might wonder, what's a logarithmic equation? It's an equation where you see the word log. Maybe you'll see it as log, maybe you'll see the ln version. But either way, you'll see an actual word that means log written in the equation. So this one's ready to go. And if you remember right, all of these equations can be written in more than one form. They can be written in logarithmic form or an exponential form. And that is, in fact, how you solve a logarithmic equation. You make sure you have the log isolated on one side of the equal sign, and we've got the log over here, and then we rewrite in exponential form. So using the idea that this is the base, 3, and the logarithm is an exponent, so there's your exponent. 3 to the second better give me the argument. And I'll bet you can see where you'd go from here. You just do a little algebra 1 to get x alone. Subtracting 1 from both sides. And then we divide both sides by 5. Notice it doesn't have to come out to a very tidy number. There's nothing wrong with having a fractional exponent. A fractional value for x, I should say. So here we are. We have found the value that x can be that would make this statement true. You've just solved your first logarithmic equation. Isn't that exciting? So this one was kind of made easier because the log was already isolated. Let's take a look at another problem. Screenshot this if you want, because I'm about ready to erase it. And I'm erasing it. Okay, so now we do example 2. And with example 2, I'm going to give you 3 log to base 2 of x plus 10 minus 1 equals 14. Something like that. Now, one thing I have not mentioned, perhaps I thought this would be obvious, but this right here, this whole thing belongs together until the very end when we actually rewrite it in an exponential form. You can't, for instance, take an equation like this and start doing arithmetic that involves the x or the 10. So this all has to stay together, looking just like this, until we rewrite it in exponential form. All right, so let's take a look. In this case, do you see the word log and its argument is not isolated? This is an extra term, and this is a multiplier. So we've got to isolate this first. So let's take the term that doesn't have any log in it and bring it over there by adding 1. So 3 log to base 2 of x plus 10 is equal to 15. Now it's time to get rid of this guy because we're trying to get this alone. So we're going to divide by 3 on both sides. When we divide by 3 on both sides, this is where I meant if this 3 went into some number that could have been in here, can't touch this. So basically, divide the 3 by the 3, divide the 15 by the 3. The log to base 2 of x plus 10 is equal to 5. Now that we have this all alone, it's time to rewrite it in exponential form. So we say 2 to the 5th power is equal to the argument. Okay, and now this is a 32 is equal to x plus 10. And therefore, when we subtract 10 from both sides, we see that x is 22. I should mention something here. It hasn't happened yet with the 2 problems that we've done. But if ever this number here comes out to something that when you put it in here in your original equation, you will have to rule out that answer if it causes the argument to be negative. So 22 plugged in here, that comes out to 32, is not going to be a problem. We're going to keep this answer. But if plugging the 22 into here makes that become out negative, we would have to discard that value. That would be called an extraneous root. The reason for doing that we haven't really explained yet, but it has to do with logarithms and exponentials and their domains and ranges. So I might make a little separate short video on that. But notice we got the word log alone with its argument. Then we rewrote it in exponential form. 2 to the 5th is the argument. And then we solve that just like usual. At this stage, once you've rewritten it, it should look like a kind of an equation that you've done before. Let's take a look at one more example. So again, screenshot this if you'd like to have that preserved for you. Wouldn't be a bad idea for you to put these right in your notes anyway. See if you can stay a step ahead of me, especially when we're about to do the third one of these. If you're getting the hang of it, it's good to see if you can stay ahead of the game. So this next equation isn't going to be very long. Here we go. Now what makes this be a logarithmic equation is you see either log or ln somewhere in the equation. With that in mind, the word log and its argument are already isolated, so we're ready to actually write it in exponential form. Now, do you remember that when the base is not written out, it's either a 10 or an e, and if it's ln, it's an e down here. E was one of those weird little numbers like pi, in that it never stopped, the digits keep on going, and it never had a repeating block. So let's go ahead, and it's ready to go to write in exponential form. E to the third gives me this thing. The base to that power. Now if I asked you how many variables are there, there's actually only one thing that varies, it's x. Okay, this is not a variable. This is a constant that's just more conveniently written as an e. This is about 2.718. So when we try to solve for x, we're going to be getting an expression that involves numbers, but we're not going to get a number that's an integer as an answer. So at this stage, I'm trying to find x. Let's subtract 4 from both sides. So e to the third minus 4 equals, and then when we subtract 4 here, we're left just with x. This is a perfectly legitimate way to write your answer. If you were trying to know the value decimal-wise, you could evaluate this with a calculator. You would use the e or the e to the x button that's on your calculator, but you could get this in a decimal form. Okay, but basically, it's kind of like this will come out to a positive number, because e to the third, 2.718 to the third is like 9-ish. So that's, and then minus 4 is around 5. And that's going to have no problem here making that argument be positive. So we're done. And that's this lesson on solving logarithmic equations. I hope this was helpful.